Hey everybody. So today we're going to be going over a LeetCode problem. We're going to be going over the same tree 100 LeetCode problem that's commonly used by or used in Google interviews. I personally have never been asked this on the few interviews I've actually gone on, but I think it's a really good practice, a really good problem to practice recursion on and how to traverse through different types of trees. It's a pretty simple problem, so let's go ahead and just get right into it. Alright, so let's go ahead and just go over the problem. So given two binary trees, write a function to check if they are the same or not. Okay, two binary trees are considered the same if they are structurally identical and the nodes have the same value. Okay, so let's go ahead and take a look at their examples. So in example one, we're given two trees as our input. Both start off with a 1 at the root node, and both, when you traverse to the left, have a value of 2, and when you traverse to the right, they have a value of 3. So in that case, since the root node is the same, the left half of the tree is the same, and the right half of the tree is the same, we would return true since they're structurally and they have the same value. Sorry. Okay, so in example 2, we would actually return false in this one because when we traverse to the left on the left tree, so on this first one, right here, when we traverse to the left, we have a value of 2, but when we traverse to the left on this second tree, we have a value of null. So in that case, they're not structurally the same, so it would return false. And in the third example, again, both of the trees have the same root value. However, when you traverse to the left on the first tree, your value is 2, and when you traverse to the left on your second tree, your value is 1, making them structurally not identical. So we would also return false. So we could traverse through this tree just using some recursive calls. And if we're going to be using recursion, we're going to need a base case. So let's go ahead and write this. So our base case could be if P is equal to null and if Q is also equal to null, that means we've either been given null trees or we've traversed all the way down to the value after the last, which is null, and making it all identical. So we can say if P is equal to null and if Q is equal to, oh, it's not null, sorry, it's none in Python. Okay, so if they both have a value of none, then we're just going to return true. And now our second possibility is like in example 2. So if the P's left value is not equal to the Q's left value, then they are not the same, so we're going to return false in that case. So what we can say is if P dot left is not equal to Q dot left, then we will return false. And then we're going to make this an else if. And actually, we're going to add one more right under here. So for this one, let me add this. So with this one, our base case is going to be, okay, so if P is none and if Q is none, we're going to return true. However, we could be given the case where P has a value of none and Q actually does have values, making them not identical because one has values whereas the other is whereas the other doesn't. So we'll say if P is equal to none, or again Java, or if Q is equal to none, then we're also going to return false. And then let me wait. Oh, what am I doing? Whoops. There we go. Okay, and then we'll keep this one, and then our last one is just going to be our recursive case. So if we did not satisfy, or if none of these conditions are met, then we're just going to traverse to the left and we traverse to the right and then check these values. So we will go ahead and return self dot is same tree, and we're going to go ahead and traverse to the left. So we'll say P dot left, and then we'll also traverse the second tree to the left. So we'll say Q dot left. So we're going to compare this with, oh, nope, not Java. We're going to compare this with the right values. So we'll say self dot is same tree, And then instead of going to the left, we're going to be going to the right for both P and Q. And I believe that is it. So let's go ahead and run this and see if this works. Wrong answer. Okay, let's see, what did we, so if P is equal to 9 and Q is equal to 9, return true, else if P is equal to 9 or Q is equal to 9, return false. Oh, okay, so sorry, we're not going to be doing P dot left, and I don't know why I said that. We're going to be doing P dot value, because we want to compare the values. So let's say we get down to this statement, and we traverse to the left on the P tree and on the Q tree. So we'll be here and here. This third else if statement is going to be comparing, okay, well, what is the value of this one and this one? And if they're the same, or I'm sorry, if they're not the same, then we'll return false. Okay, so this should work. Woohoo! Okay, so let's go ahead and let's submit this and see how well we did. And nice, cool. So this is the fastest I've been able to do this one so far, and I've actually used up the most memory though. But yeah, that's the solution for LeetCode 100. Go ahead and leave a comment asking me to do another problem. But yeah, I'll see you next time.